Hello, everybody, and welcome to this fourth and final lecture of our online evolution course. Today, we're going to go over the Hardy-Weinberg formulas. Now, last week we went over the Hardy-Weinberg principle or Hardy-Weinberg equilibrium, which stated that allele frequencies in a population will not change unless some outside force causes them to change. Today, we're going to go over Hardy-Weinberg's formulas, which will allow you to calculate different gene frequencies in a population. So our learning objective today is to calculate the frequency of alleles and genotypes in a population using the Hardy-Weinberg formulas. I hope you enjoy it. Okay, so here are the two Hardy-Weinberg equations. The first one is P plus Q equals 1. And the second one is P squared plus 2 times P times Q plus Q squared equals 1. Now, you can use these two formulas along with a little bit of algebraic skills to determine the frequency of alleles and the frequency of genotypes in a population. So what we need to know is, what do these variables stand for? So the first one is P. That is the frequency of dominant alleles in a population. Now, if you remember from genetics, alleles can be dominant or they can be recessive. For example, blue eyes is a recessive trait. So the only way you can have blue eyes is you have to have two recessive alleles that you got from both of your parents. So P is the frequency of the dominant allele in a population. Q will be the frequency of the recessive allele in a population. So that would be like blue eyes. What percentage of the population or the gene pool has the recessive allele? That would be Q. P squared is the frequency of individuals which are homozygous dominant in the population. So if it was eye color, we'll use the letter B. Big B would be for brown or non-blue eyes. So P squared would be the percentage of individuals which would have the genotype of big B, big B. 2 times P times Q, or 2PQ, would be the frequency of heterozygous individuals in the population. Now, in this example, they would have brown eyes because they have one dominant brown-eyed allele, but they would have the genotype of big B, little b. And finally, Q squared would equal the frequency of homozygous recessive individuals in the population. So Q squared would equal the percentage or frequency of people that would have blue eyes. All right, so now we're going to try a sample problem. So here we go. In a population of people, 17% have blue eyes. Now, if you remember, 17% is the same thing as saying 0.17. What are the frequency of the dominant and recessive alleles in the population? How many individuals would be homozygous dominant for brown eyes? How many would be heterozygous for brown eyes? And how many would be homozygous recessive and have blue eyes? Now you can see there, brown eyes is signified with the big B allele because it's dominant, and blue eyes is signified by the little b allele because it is recessive. So we're going to try to figure out all of the variables. P squared would equal the frequency of being homozygous dominant or big B for brown eyes. Q squared would be the frequency of homozygous recessive, little b, and that would be the percentage of individuals which actually have blue eyes. 2 times P times Q would be the frequency of heterozygous individuals, big B, little b, who would also have brown eyes because they have one dominant allele. P would be the frequency of the dominant allele in the gene pool, and Q would be the percentage or frequency of the recessive allele in the gene pool. And you can see that we still have our two equations there. P plus Q equals 1, and P squared plus 2 times P times Q plus Q squared equals 1. Okay, so now I'm going to quickly show you how to do the math with this Hardy-Weinberg sample problem number 1. Now, if you remember from the previous slide, 17% of the individuals in this population had blue eyes. Now, another way to say 17% is say the frequency of people with blue eyes is 0.17. Now, the only way you can have blue eyes is you have to have the genotype of little b, or you have to be homozygous recessive. Now, which of our variables means being homozygous recessive? Well, the answer, of course, is that would be Q squared. So Q squared would equal 0.17. Now that we have Q squared, it is easy to find Q. Just plug into your calculator 0.17 and find the square root. And if you do that, you will get Q equals 0.41. All right? So now we're going to use the formula of P plus Q equals 1, and we're going to find out what P equals. Well, since Q equals 0.41, P would have to equal 0.59, because 0.59 plus 0.41 would equal 1. So now that we know that P equals 0.59, we could easily find out what P squared is. All we do is we use our calculator, plug in 0.59, and square it. And if you do that, you will get 0.35. Finally, we'll figure out what are the frequency of people who are heterozygous and have brown eyes, or what is 2PQ. So all we would do is 2 times P, which is 0.59, times Q, which is 0.41. And if you do that on your calculator, you will get 0.48. So the frequency of the dominant big B allele in the population is 0.59 or 59%. The frequency of the recessive allele, little b, will be 0.41. The frequency of homozygous dominant, blue-eyed individuals, little b, will be 0.17. The frequency of homozygous dominant individuals, or big B, would be 0.35 or 35%. And 2PQ, the frequency of heterozygous, would be 0.48. And those individuals would have the genotype of big B, little b. Okay, so now we're going to try the Hardy-Weinberg sample problem number 2. Here we're going to look at dimples. Now, if you see there, dimples is a dominant trait. So you can have dimples by having one dominant allele or two dominant alleles. The only way you do not have dimples is you got to have two recessive alleles or little d genotype. Now, in this problem, 80% of a population, they do not have dimples. So 80% of the population does not have dimples. So what is their genotype have to be to not have dimples? Since this is a recessive trait, the only way you do not have dimples is you got to have the genotype of little d. Now, which of our variables is the frequency of individuals who are homozygous recessive? If you said that's Q squared, give yourself a pat on the back because you are correct. So Q squared has to equal 0.8 because 80% of the population don't have dimples, so they have to have the genotype of little d. Now, since we have Q squared equals 0.8, to find Q, just insert that into your calculator and take the square root. And if you do that, you will get Q equals 0.89. Now, since Q equals 0.89, using the formula of P plus Q equals 1, if Q equals 0.89, P would have to equal 0.11 because 0.11 plus 0.89 equals 1. So now that we have that P equals 0.11, we're going to enter that into our calculator and we're going to square it to get P squared. So putting that in our calculator, 0.11 squared, I'm going to round it off, equals P squared is going to equal 0.01. So now the final variable we need to find is 2 times P times Q. So 2 times P, which is 0.11, times Q, which is 0.89, equals, I'm going to round it off, 2 times P times Q equals 0.19. So now we got all our variables. P is the frequency or percentage of the dominant allele in the gene pool, or the big D. Q is the frequency of the recessive allele in the gene pool, or little d. Q squared is the frequency of homozygous recessive individuals in the gene pool, or little d. P squared is the frequency or percentage of homozygous dominant individuals in the gene pool, or big D. And 2pq is the percentage or frequency of heterozygous individuals in the gene pool, or big D. And that's all there is to it. I want to thank you guys for listening to all my lectures. I hope you enjoyed them, and feel free to join one of my other e-learning courses in the future. Thank you very much. Goodbye.